Ladies and gentlemen, welcome back. Welcome to my next lecture on electrical engineering, electricity, and magnetism. I hope you enjoyed my last lecture. In today's lecture, we will be again looking at Kirchhoff's law, and we'll be solving some numerical problems related to Kirchhoff's law. We'll also go over some exam type questions. So let's directly go to the content. So electrical engineers, we step up, we transform. So let's step up and let's try to solve some complicated circuits on Kirchhoff's law. Before I take up the topic again, let me quickly go over the content that I discussed in my last lecture. We mainly talked about Kirchhoff's rules, Kirchhoff's rule number 1 and Kirchhoff's rule number 2. So if you look at Kirchhoff's rule number 1, it states that the algebraic sum of the currents at each junction is 0. So if you were to look here, this red dot, that represents the junction. So the algebraic sum of currents, so technically the currents that are entering and the currents that are leaving, their sum has to be 0. Here you have I1 entering, here you have I2 leaving and I3 entering. So if you give I1 a positive sign, so I3 and I1 will get positive sign because they are the currents that are entering to the nodal point, and I2 is the one that is leaving out. So I2, you can assign a negative sign. So your equation would be I1 minus I2 plus I3 is equal to 0. So try to understand rule number 1. The algebraic sum of currents at any junction is equal to 0. You could apply the same rule for the next junction here. And here, if you see, I2 is the one that is entering, and I1 and I3, they are leaving. So your equation would be I2 minus I3 minus I1 is equal to 0. That's rule number 1. I hope rule number 1 is clear to all of you. Let's talk about rule number 2. Rule number 2 states that the net potential in any one loop, like here, if I'm talking about this loop, so let's say I have this loop, so the net potential along this loop is equal to 0. Now, when you are actually solving numerical problems in loop type circuits, the important thing that you need to know is if you are moving in the direction of the current, take that as negative. And if you're moving opposite to the direction of the current, take that as positive. And that is what here it shows. Here you see, if you're moving in the direction of the current, take that as negative. And if you're moving opposite to the direction of the current, take that as positive. Now, when it comes to electrical cells, if you are moving from negative to positive, there is a step up in the voltage, so that has to be taken as positive. And if you are moving from positive to negative, there is a step down in the voltage, and that has to be taken as negative. Now, you could apply that rule here. So let's say if you start from here, this E1, you're going from negative to positive. So this is positive E1, this is positive E1, but then you are going into the direction of the current and along V2. So you see that would be negative. Here I have used the concept of energy, but I'll just revisit here. You see, you will have E1 positive, then this V2 would be negative, V4 would be negative. Then in E2, you are traveling from positive to negative. So this would be negative as well. And then again, V1 is going to be negative. So here you see, if you start from this point, you could start from any point. Let's start from this point. So if I start from this point, I'm going from negative to positive. So this becomes positive E1. You see positive E1. I'm moving into the direction. So there is a drop in the voltage. So that becomes negative V2. Then again, I'm moving in the direction of the voltage. So you see that would be negative V4. Then here, look at the second cell. You are moving from positive to negative. So that would be negative E2. And again here, this would be negative V1. And that should equal to 0 because the rule says the algebraic sum of the voltages or the net voltage along the loop has to be 0. Now, if you look here, you could apply the same thing. If you are moving into the direction that is negative, if you are moving from positive to negative, that has to be negative. And if you were to apply this rule here, let's say you are going from positive E2 to negative E2, so that makes it negative E2 minus V3 because you're moving into the direction of the loop. So if you have taken this as the direction, you are moving along the direction. So this is negative V3. And again, this is going to be negative V4. All right, so let's start with the numerical problems now. This numerical problem is from the Sears and Zeminsky University Physics book. I want you guys to pause the video and try solving the question. There are two questions there. You see 26.25 and 26.26. I want you guys to solve first 26.25. So this circuit problem, try solving it. You have two batteries. You have a 28-volt battery. You have a resistor R. You have another EMF battery whose EMF is unknown. And then you have the 6 ohm resistor with 4 ampere current flowing through it. And here you have 3 ohm resistor with 6 ampere current flowing through it. So pause the video. I'm going to give you 5 minutes to work on this question, and then we can go over the solution. All right, I assume you solved this question. So let's quickly go over, you guys have completed this. Okay, so let's go over the solutions now. So let us try to understand how to solve this question. Now, let's look at loop 1. This is loop 1. I'm assuming that the current that moves from this cell is I1. So this is the current that is going I1. And then you see the current that is going from loop 2, here you see in loop 2, this is the current I2. This is the current I2. Oops. All right, so here we start with, I'm talking about this loop. So when I'm talking about, so just a moment, spotlight, okay. So make sure I have that spotlight. Okay. Now, if you look here, so this is 28 volts and the current is moving in this direction. So we start from here. So we start from the negative. So negative to positive. So there is a step up. So that's positive 28. And then this current I1 is flowing. Now, as you reach here, this you are moving from positive to negative. So there is a drop. So this is going to be negative E. I'm taking this as E. So this is going to be negative E. And then as you go here, you are moving opposite to the direction of the current. You see the current is 4 amps and this is moving in this direction, but you are actually moving in this direction. So this is going to be positive because if you're moving in the direction of the current, that will be negative. So there is a voltage up. So you see 4 multiplied by 6 here. And as you go up, you have the current I1. I1 times R equals to 0. So that's your first loop. That's the equation for the first loop. And then for the second loop, if you were to talk about the second loop, you see you start from here. The I2 is the current that is flowing here. And this is moving in the direction. So this current is in the direction what we have taken. So there will be a voltage drop. So you could write down that equation for loop 2, that E minus 6 times 3 because the resistance is 3. So E, so this is E minus 6 times 3 multiplied, and then when you go up, minus 6 times 4, because again here, if you see, you have the voltage drop because you're moving in the same direction as that of the current. So you have both the equations. So you have the first equation here, which gives you 52 minus E minus I1R is equal to 0. And then you have the second equation, which says E minus 18 minus 24 is equal to 0. Now, if you solve this, you can directly get the value for E here. If you see you can directly solve for E and you get E as 42. Now, if I sub in the value of E here in the first equation, I can have 52 minus 42 minus 2 multiplied by R. That is equal to 0, and that will give R as 5 ohms. So you see, the first part we already solved. The current in, okay, the current in the resistor R, we need to find the current in the resistor R. So we have I1 and I2, that is 6. If you look here, this is 6 ohms. Sorry, this is 6 amperes, and this is 4 amps that is moving out. So obviously the current that is going here must be 2 amps, because if you look here, this current is coming here and this current is coming here. They both combine together. The current from the first battery is going like this. The current from the second battery is going like this. They both combine here to become 6 amperes. Now 4 amperes goes out. So the remaining 2 amperes goes up. So the current through the resistor R is going to be 2 amperes. That's the first part of the question they had asked. Resistance of the cell, we already raised, sorry, resistance of the resistor, that's 5 ohms. Here you see we just solved that for 5 ohms. EMF we calculated from the second equation, which gave E is 42 volts. And the last part was if the circuit is broken at X. So if you break the circuit as X, that means if you break the circuit at X, it means no current can flow along this branch. If no current can flow along this branch, you can remove this branch completely, and you will then have a resistor 3 ohm as well as a resistor 5 ohm here that you have calculated. This one, which is a 5 ohm. So you add them together. So the total resistor is going to be 8 ohms. The total resistance rather is going to be 8 ohms. And the current is V over R, which is 28 divided by 8, and that gives you 3.5 amperes. Double check your work and reflect on your understanding. Here comes your next problem. Look at this problem. Now you have the cell, and you are given the voltage. There is a current 1 ampere flowing here. There's a current 2 amperes flowing here. And this E1 and E2, they are unknown. And the question asks you to calculate what is the value for E1 and E2. Now, if you start solving using the Kirchhoff's law, you'll get an equation something like this. So let's talk about loop 1. If you talk about loop 1 here, let's say this is 20 volts and this is 1 ohms. So you have this as the loop 1, and then you have this as the loop 2. So let's start first with the loop 2. E1 is unknown here, you see, you don't know what is E1. E1 minus. Now, how do you know this is 1 amp flowing through this resistor? Well, if you look here, 1 amp is flowing here, 2 amp is flowing here. That means 1 amp must be flowing in this direction. That is how they can combine at this junction to form 2 amps. So we get 1 amp flowing through here. Now 1 times this resistor is 1 ohm. So 1 times 1, that is 1. Then again, 4 times 1, that is 4. And then as you go here, you have 2 times this resistor. And that is 2, because 2 times 1 is 2. And then because 2 ampere is the current and 1 ohm is the resistor. So 2 times 1 is 2, and minus E2 because you're going from positive to negative. So that is minus E2. And then again here, 2 times 2 is minus 4. That is equal to 0. Now from there you could get E1 minus E2 is equal to 11. That's your first equation. Now look at loop 1. In loop 1, when you're trying to solve Kirchhoff's law, you see you are moving in this direction. You start with 20 because you're going from negative to positive. So that's 20. 20 minus 1 because the current here is 1 and the resistance is 1 ohm. So 1 times 1 is 1. And then if you look here, if you are moving in this direction and this current is moving in this direction, so you will have 1 times 4, but this time it would be a positive 4 because you're moving opposite to the direction of current. So that becomes 4. Again, 1 times 1, positive 1, minus E1, and because you're going from positive to negative. And then here, if you see, you have the current 1 ampere flowing here and 1 times 6. So there is a voltage drop, and that would be -6. So you have your second equation now. So you had your first equation, E1 minus E2 is equal to 11. You have your second equation, which is 24 minus 6 minus E1 is equal to 0. Solve this equation and you get E1 as 18 volts. Now, once you have E1 as 18 volts, you could substitute the value of E1 in the first equation, and you will get the value of E2 as 7 volts. Now, there was another part of the question which stated that calculate the potential difference between A, B. Now, if you look here, the current is flowing in this direction. Now, if the current is flowing in this direction, the potential at A is greater than the potential at B. So let's try to find out what is the potential difference between A and B. So if you look here, you have the 18, this E1 is 18. So 18 is the voltage, and this are the voltage drop. So 18 minus 1 times 1, 4 times 1. So that gives you 18 minus 4 minus 1, and that's 13 volts. So double check your work, reflect on your understanding, and make necessary corrections. All right, next we have another question where we'll take up a question related to a little bit complicated circuit. Now here you have the cells, you have the resistors, you have the current, as well as you have a circuit, or you have a branch on the top as well. So pause the video and try solving this question. This is another question that has been taken from the Sears and Zieminski University Physics book. All right, let's go over the solution to this question. Now, in this question, what I could do is I can divide the circuit into 3 loops. I have loop 1, I have loop 2, and I have loop 3. Now let's start with loop 1. So you have E1, and the current, let's say, flowing is I1. So 4. So, oh, the current is already given. So you don't need to, I mean, you can just think that I1 is 3 amps. So 4 times 3 minus, as it goes here, and of course there's a voltage drop. So that is the reason why it is -4 times 3. And then if 3 amperes reach here, and similarly 5 amps reach here, they both combine and go together as a unit, and the total combination is 8 amperes. So now what you could write is E1 minus 4 times 3 minus 8 times 3 is equal to 0. And that's the equation for this first loop. Remember, when you are moving in the direction of the current, there is a voltage drop. And this can help you to calculate E1 as 36 volt. Let's look at E2. Now you're going from negative to positive. There is an increase in the voltage. So you can write positive E2. I2, the current 5 amps is moving in this direction. So there is a voltage drop here. So you could write 6 times 5, which is 30. So E2 minus 30 minus, so E2 minus 30 minus 24, minus 8 times 3, that is 24. And that gives you E2 as 54. So you solved E1 and E2. You are also requested to solve the resistor. So what you could do is you could now draw another loop. And in this case, you can start from here. You could have E1 because you're going from positive to negative. Then E2, you're going from negative to positive. So here, this is positive to negative. So you could write minus E1. Or you could, if you want, if you go in this direction, you could have positive E1 minus E2 minus 2 times R is equal to 0. And E1 is 36. So that's actually negative 36, because this one would be negative E1. This one is going to be negative E1, and E2 is going to be positive. So that's positive 54 minus 2R is equal to 0. There is an error here. You have to make sure that this is negative E1. This is negative E1. I forgot to write the negative sign here. So because this is going from positive to negative, so this is negative E1 and positive E2, this positive E2. So here the calculation, while putting the numbers, this has been corrected. So because here you see E1 is negative 36 and E2 is positive 54, minus 2R is equal to 0, and that gives you R as 9 ohms. So that was the third numerical, pretty heavy, right? Okay, let's talk about the fourth numerical. So let's talk about the last numerical. This is the last numerical for this lecture. Look at the circuit. You have a circuit where you have two cells. You have 10 volt, 20 ohms, 5 volts, 10 ohms. And of course, you have two resistors here as 3 ohms and 4 ohms and 10 ohm resistor. Now, what are you asked to calculate? You're asked to calculate what is the current in each branch and what is the potential difference between A and B. I would advise you to pause the video and then reflect on the solution. So let's go over the solution. All right. So here I'm taking the bigger one as loop 1. I'm going from this direction to this. And the loop 2, I'm taking this one as the loop 2. So let's start from here. I'm starting from pause. This is 10 volts. So negative to positive, that is 10. Minus 2I1, because the current here, if you see here, 2 and I1 is the current and the resistance is 2 ohms. So this was 2I1. And now I2 current is flowing in this direction. Here you see I2 current is flowing. So I1 and I2 combine here and they form I1 plus I2. So you could write 10 minus 2I1. And now if you look here, I1 and I2 combine together. So you will have minus 10 times I1 plus I2. And then as you go up, this is negative 3I1. So that's for loop 1. You start from here. So this is negative and this is positive. So that's 10 volts, 10 times 2I1. And as you go here, I2 combines with I1. So you have negative 10 I1 plus I2. And then here it becomes negative 3I1. That's equation number 1. Rearrange the equation and you will get a nice equation. 15 I1 plus 10 I2 is equal to 10. All right. Let's talk about the second loop. You have this loop here. In this loop, we are starting from here. So this is negative and this is positive. So this is positive 5 volts. So 5 minus 1 I2 minus 1 I2. And they both now combine together here. So that becomes minus 10 I1 plus I2 and minus 4 I2 because here I2 current is flowing in this loop. I1, it goes like this. I1 and I2 combines here. They both combine together and move. And at this point, I2 continues to go in this direction and I1 continues to go in this direction. That is why when I'm talking about resistor R, or when I'm trying to calculate the voltage across the resistor R, resistor 4 ohms, I'm using the current I2. So here you see 4I2 and you get a nice equation. 10I1 plus 15I2 is equal to 5. Now you are allowed to use graphing calculators, TI-84 or TI-Inspire in your exam. So plot these graphs on TI-84 or TI-Inspire, and this is where I plotted the graph. And you see the point of intersection. The point of intersection is 0.8 and negative 0.2. So that is my current. So I1 is 0.8 and I2 is 0.2 negative. So that means the direction of current I2 that we have taken is actually opposite to our assumed direction. So that's how you solve for I1 and I2. The last part of the question was, you were asked to calculate what is the voltage drop between A and B. So all you can do is 4 times the current here is I2. So 4 times negative 0.2 and then plus here the current is because it is drop, the voltage is being dropping here. So you could actually do negative 8 multiplied by 3, and that would give you negative 3.2 volts. So that brings end of this lecture. I hope you had fun solving Kirchhoff's law problems. Remember, we are living in difficult times, but I want to tell you that no resistance, in my language of electricity, no resistance can drop our potential. May peace be amplified and may world be rectified. Keep watching my videos and subscribe to my channel. Thank you.